Hi, I'm Richard, and in this video I would like to connect three observations. One of them is that wet paper is quite easy to tear. The other is that oil doesn't mix with water. And the last one is that soaking paper in oil doesn't make it any easier to tear it. So how are these three things connected? Can you make a model that will explain it very well and predict maybe even some more stuff? Yes, we can. And there's like many different models you could come up with, I think. But I want to create a very simple one where I will not use any words like atoms or molecules, and therefore the model will not be completely correct. But I find it very interesting that you can come up with a very simple model that has even predictive power, which means you can figure out things that you haven't tried before based on that model. So let's start with the question, why does dry paper hold together in the first place? Well, imagine that you have a sheet of paper and there are these little chains in the paper, and it's very hard to tear this chain apart. This doesn't happen. But actually what happens is that you can separate the chains. You can make them far from each other. And when that happens, when the chains are far apart, that means that the paper has already been torn. Now, also, one thing to note is that in paper, in a real life, there's so many of these chains and they are in all directions, and it's just very messy. So I drew only 4 chains, but the concepts are still the same. You tear paper by separating the chains from each other, and you cannot really tear the chains along its length. Okay, so if we tear the paper by separating the chains, what holds the chains together? And actually there's a nice way how to think about that. Imagine that on these chains there are little creatures, and they are very friendly, and they are friends with creatures that are on other chains, and when they are together they are very happy. But what happens when you are tearing the paper apart? Well, if you have paper in one piece, then all is well, the creatures are still friends. But if you separate the paper in 2 pieces, then some creatures will be too far from their friends. They will have no one to be friends with, and they'll be very sad. And this is actually a nice way how to think about why it's hard to tear paper. Because when you are tearing paper, you are separating the paper chains apart, which means that you separate some friends, and they are unhappy, and they want to resist you. And that's what you experience as the force against tearing the paper. Okay, but we can make that paper to be much more easier to tear if we just wet it in water. So how does water help it? How could anything make paper easier to tear? It would be easier to tear if the creatures didn't resist tearing, but they don't like being apart from each other. So why wouldn't they resist it? Well, if you could make them happy, even though when they are far apart from each other, if they would be happy, they wouldn't have preference between the paper being torn apart or being in one piece. So the question is, what would make them happy, even though the paper would be in 2 pieces and they would be far apart? Well, that's where water comes in. You can think about water as being a big ball which has 4 creatures on it. Creatures are the same creatures as are in the paper chains. You have more waters next to each other, like here, then the creatures will be friends with each other. And if you wet paper, well, what happens? Nothing surprising happens. It's just that the water molecules, or the creatures on the water molecules, will become friends with the creatures on the paper chains. Now, the creatures on the paper chains have friends even though they are separated from their original friends. So basically they don't mind whether they will be in one piece where they will be friends with creatures on other paper chains, or whether the paper will be separated and they will be friends with creatures that are in the water particles. And because they don't have the preference between the paper being torn apart or being in one piece, they won't resist you when you are trying to tear the paper. Okay, but what are these pictures good for? Well, we can try to connect the 2 things we are interested in. Why paper soaked in with oil doesn't tear more easily, and why water and oil don't mix. I mean that when you try to put them in one pot, they will stay separated, unlike, say, juice and water. And to explain this, we have to look at what oil is composed from. You can think of oil as being composed from like this kind of blobs, and these blobs, they are not necessarily grumpy, but they are not friendly either. So the creatures that are in the paper chains or in water, well, they don't really like being around these blobs, but rather they prefer to hang out with each other. Okay, but how could that explain that water doesn't mix with oil? Well, imagine these two pictures. Here on the left side, you have some water and you have as well oil, and they are well separated. Because of that, most of the creatures that are in water have their friends around, and they have a lot of friends around, so they are very happy. Like, of course, except of those who are on the corners, they don't have any friends. But if you look, what happens if you mix oil with water, you see, there's no easy way how to separate them now. Then what happens is that a lot of the creatures, they don't have any friends around, and those who do, they have only one, and that's very sad actually. So they don't like this, and if they can choose, and they can, they choose to be separated because they have more friends around each other. This model also explains why oil doesn't make it any easier to tear the paper, because even though there is some liquid on the paper when there's oil, the creatures that don't like the blobs which oil is made from, well, they can't be friends with them. So they are unhappy, and as they are being more unhappy as the paper is being torn, because they are separating from their friends, they try to resist that, which is the same case as if the paper was dry. But these are all things that we already knew. We knew that oil doesn't mix with water and it doesn't make easier to tear the paper, and we knew that water makes easier to tear the paper. But can we predict something we don't know? And partly yes. Let's consider this example. Imagine that you are interested in whether ethylene glycol, whatever that is, it is just some liquid, or cyclohexane, which is another liquid, whether they make it easier for paper to tear. Can you think of a way how you could figure out that before you actually try it? Well, the way I would go about this is that, okay, I would first ask what they are composed from. How their particles look, and more importantly, do they have any friendly creatures on them? If there were the green creatures on the particles of either ethylene glycol or cyclohexane, they could be friends with the creatures on their paper chains, even when the paper chains are far apart, and that would mean that the paper creatures would not mind being separated from their original friends, and they would not resist the tearing. So actually, if a particle of one of these compounds, or both of them, would have the green creatures on it, it would make it easier to tear. Well, that's great, but hey, we don't really know how the particles of these compounds look. Like, when you look at the liquid, you can't see the particles. So is there a way how we could figure out whether there actually are these green creatures or not, without trying to tear the paper? Yes, there is, and probably the simplest way is just to try mixing it with water, because as we saw previously, if something doesn't have the creatures on it, then the water creatures will lose friends when they mix with that compound, and they will be sad, so they won't mix and they will stay unmixed. But if there would be creatures on the particles of something, say in oil, which there are not, then the water creatures would have still friends, even though they would mix with oil, and they would be happy and they would mix. But that's not the case, so we know that oil doesn't have any creatures. And we can use this kind of thinking to try to predict whether cyclohexane or ethylene glycol will make it easier for the paper to tear, even without trying that. How can we do that? Well, first, the question is, are there any green creatures? Well, how do we find that out? because we don't know how the particles look? Well, we try to mix them with water, and if it mixes, then it means that there are these green creatures because they can be friends to the water particles, and because there are these green creatures, they can also be friends to the paper chains, which will make it easier for them to separate, because they will still have friends even when they are separated, which will make the paper easier to tear. But if we try to take this substance and mix it with water, but there's no mixing, then it means then the structure of the substance is kind of blobbish, and because water molecules are not friends with these blobbish things, and if they don't mix with them, that means they are not friends, so probably there are no green creatures there, and because there are no green creatures there, it also means that it won't make tearing paper any easier. This is all nice, but does it really work like that? Well, I will show you a video of how I'm trying it in lab, and see for yourself. On the left there's ethylene glycol, and on the right there's hexane. First, I will try whether ethylene glycol will mix with water. Hopefully you can see that they indeed mix. There is no border between water and ethylene glycol. Now I'll try to mix hexane and water. And as you can see, they don't mix. Above my thumb, there is the border between water and hexane. So what I will do now is put ethylene glycol on the red strip and put hexane on the right strip, and I will leave it to soak in. Okay, so I have left it to soak in, and I will try to tear it apart. And you see, it was torn where the ethylene glycol it was as we predicted. So, as you could see, in this case, it worked according to this diagram as we predicted. But frankly, it doesn't always work like that. It is more complex, which I guess shouldn't come as a surprise, right? Because, I mean, things are not blobbish or there are no friendly creatures, but there's something else going on. And if you are interested in what, well, I'll make a video about that, where I kind of explain how the concept of atoms and molecules, which is the usual way how you think about substances around us, can give rise to these friendly creatures or these blobbish things. So thank you for watching and see you in next video.